Hey everybody, this is Professor Ross, and in this video we'll be talking about comparing the means of two groups. So we're going to have a single binary categorical variable as our explanatory variable, setting up our two groups, and a single quantitative variable as our response variable. Let's take a look at a few notes here. So we're comparing two groups and a quantitative response. And our key learning objective throughout this unit is going to be to use the logic of statistical decision making. So we're going to think about the logic of how we can compare two groups, especially as we get into statistical inference in the next couple of videos. So how can we explore quantitative data for two groups? Well, one of the ways we can do this is create side-by-side dot plots, a dot plot for each of the groups to take a look at the quantitative data. The multiple means applet will do this. So we're going to use the multiple means applet to examine Old Faithful times between eruption data from 1978 and from 2003. So our two groups, 1978 and 2003, and the quantitative data is going to be the time between eruptions. We're going to use the dot plots and compare shapes, centers, variability, and unusual observations. So I'm going to pull up the applets and I want to walk through how to put some data into the applets because we're going to be doing that quite a bit in the next few chapters. We're going to use the multiple means applet because that's a way we can compare multiple means and specifically the means of two groups. It has some default data in there. I'm going to clear that data out and I need to go get some other data to put in here and then hit use data. Now I could type data in, but they have a lot of data sets here that I'm going to be asking you to use. And the one that I'm going to use right now is chapter 6, example 1, Old Faithful. So I click on that and you'll see I have a lot of data here. And one way to get it is to click and drag to highlight all of it, but I prefer on a PC to press Control A, and that highlights everything. And I know I'm not missing anything when I use Control A. If you're on a Mac, it's Command A. From there, I can right click and choose copy, or you can choose Control C to copy. And then here, Control V will paste it, or you can right click and paste it. One thing to double check after you've hit use data, if you know your sample size, what you're supposed to have, double check that you have the right sample size and you got all your data included. When you use Control A, it should copy all the data for you. So now we've got data in here and you can see we've got a categorical variable year. So what year was it? Either 1978 or 2003. Those are our two different years. We looked at times between eruptions and that's our quantitative variable. And you can see the categorical here, 1978 or 2003, and our quantitative results, the time between eruptions ranging from, looks like maybe 40 up to a high of maybe around 100. So side-by-side dot plots, we can now look at key things like the shapes. And it's kind of interesting. In the 1978, we've got kind of a bimodal shape where we've got two main humps. And in 2003, there's still somewhat of that bimodal, two main peaks here, but less spread out. Um, so a little bit less of two distinct groups there in the shapes. How about centers? If I had to choose a center for the 1978 data, I'd say the typical time between eruptions was probably somewhere around, I don't know, maybe 70, 60 or 70. Whereas in 2003, the center there, the typical time is much higher, somewhere around 95 or 100. So it seems like Old Faithful has changed in those 25 years that passed between looking at these data. So that's centers, and we can compare and see that they're different there. How about spreads? Well, the overall spread, 1978, went from about 40 up to 95 or 100. And in 2003, the overall spread went from about 50 or 55 up to 110. So we see that's a little higher there. But that bulk of data much more spread out in 1978 because we've got these two main groups and they're kind of spread. So a wider spread in the bulk of data, whereas in 2003, much tighter bulk of data here. In other words, if you went to Old Faithful in 78, you might have less of a chance of, seeing it be very faithful. Whereas in 2003, it seems like it's much more of a faithful trend, clearly somewhere around 85 to 100, and you got a really good chance of seeing Old Faithful. Lastly, on the unusual observations, we have some very clear ones in 2003, some low ones here, very short time between eruptions. Whereas in 1978, there were less. There were a few that kind of trailed off either end, but not as far away from the main bulk as we saw in 2003. So that's using side-by-side dot plots. That's a great way to explore your two groups when you're looking at uh, quantitative data. We're also going to find that there's another great way, and that is a new graph that we haven't talked about in this course called box plots. Now, you may have seen box plots before. We're going to take a little time to talk them through. They are a very, very valuable graph that too many people don't know much about. So I'd like you to find out a little bit more. Box plots are based on medians, which split the data into two halves. So we have the median is kind of the halfway point of the data, but then also based on quartiles, which split each half into halves, i.e. into quarters. So that's why we call them quartiles. So quartile 1, Q1, is the median of the data below the median, the overall median, so the lower half of the data. And quartile 3, Q3, is the median of the upper half of the data above the overall median. And if we summarize the data by looking at the overall median, quartile 1, quartile 3, that splits the data into 4 different sections, quarters. We then have a 5-number summary if we throw in the min and the max along with our quartiles and our median. And this 5-number summary gives us a lot of information about a set of data. For example, knowing the min and the max tells us about the overall spread. Knowing quartile 1 and quartile 3 tells us where the bulk of the data is. Knowing the median tells us where the center is. And seeing how these are spaced out relative to each other can help us understand where the data is packed together or where it's spread out. We can also tell if we have unusual observations if our minimum or maximum are very low or very high relative to everything else. So 5-number summary is a super helpful summary of statistics about our data. We can visualize the 5-number summary in a graph called a box plot. So let's take a look. The 5-number summary is a minimum, quartile 1, median, quartile 3, and max. And the box plot simply visualizes that by putting a mark at each of those. A mark at the minimum, a mark at the quartile 1, a mark at the median, a mark at the quartile 3, and a mark at the maximum. We then connect the marks from quartile 1 to 3 and we draw a box, and hence the name box plot, or sometimes called box and whiskers because these long lines kind of look like whiskers. The box shows us where the middle 2 quarters of the data is, the middle half of the data, and that's where the middle of the bulk of the data is. And then our whiskers extend down to the minimum and up to the max, and they help us understand where the lower and upper quarters of our data is. So we can tell about shape. We can tell, for example, the upper part of these ACT score here are more spread out. So we may have a bit of a right-hand skew because this is longer and this half of the box is longer compared to this one. The center is pretty clear. That's where the median is, right around a 24 ACT. Variability, most of our middle half of ACTs, that bulk of ACTs has fallen somewhere from 22 to 26, 20, 28 maybe. And overall, we see a range of maybe 17 up to 35. Unusual observations here, if I had an outlier, it would be marked instead of as part of the whisker, it would be marked as a star off the end of the whisker. So I don't have any outliers here. So box plot's super helpful for us understanding some key aspects of data as we explore the data. We also have a new measure of spread related to box plots and quartiles. It's called the interquartile range, and we simply subtract quartile 3 minus quartile 1, and it tells us the range or the spread of the middle half of the data. For example, if this was our 5-number summary, and we knew that quartile 1 was 22, which we could estimate from the graph there, and quartile 3 was 28, the IQR simply we calculate 28 minus 22 equals 6. And our IQR means that this box is 6 long. In other words, the middle half of the ACT scores were spread about over about 6 points. And that's what the IQR is about. We actually prefer the IQR when we have a lot of skew or outliers in our data, because the IQR is not going to be impacted by how far these whiskers go out. Instead, it's centered around this middle bulk of the data, and so it's what we call resistant to the effects of outliers. So we can also use box plots for comparing two groups. So let's jump back to the multiple means applet and we'll check the box plots box, and we'll look at the Old Faithful data and see how it can help us understand the same 4 things we're interested in: shape, center, variability, and unusual observation. So I'm going to jump back over to that graph. Let's see, where were we? Here we are. And you can simply check the box plots box, and we can see here a box plot for each year of data. And let's talk about shape. We can see a long tail toward the left on both of these, a little bit of a left-hand skew. Center, we definitely see a lower center for 1978, like we discussed, and a higher center for 2003. Longer time in between eruptions for Old Faithful in later years. How about spread? We see more of an overall spread probably in 2003, although it's probably not too different. But the big difference we see is the bulk of data is much more compact in 2003 and much more spread out in 1978. And then lastly, unusual observations, we can tell this long whisker here is going out to the unusual observations down here. I think on this multiple means applet, you do not see stars for outliers. In most other box plot drawings, you'll see some stars on those outliers. So that's box plots, and that's a great way to explore data and get a sense of what's going on when we're comparing the means of 2 different groups.